Good day, students, and welcome to your K-Factor Fluids Lab. My name is Daniel Barnard. I'm the fluid technician here at CPUT, and in this video series we'll go through your lab guide, the equipment we're going to use, how we capture the data, and all the links to the videos, data, and resources will be provided to you by your lecturer. Next clip, we'll go through your lab guide. Here's your lab guide for K-Factor. That's just the front page. Then second page we have the table of contents. Then in heading 1 we have the aim of the experiment, and the aim is to determine the K-factor for a sudden contraction in a pipeline. And in that little section it gives you the diameters of the pipelines of the sudden contraction. Then in point number 2 is what you need to do. Please read through that carefully so you know what to do. Then there's some theoretical background for this lab. There's an important equation there: head loss equals the K-factor times velocity head. Then you have a diagram of the sudden contraction in the pipeline. That is the section we're looking at. And there's some more background, theoretical background. Then the next point is the experimental apparatus we're going to use for this lab. Again, we're going to make use of the hydraulic bench, and then we're going to plug into the apparatus for K-factor. And in this picture, the part we're looking at is the sudden contraction. That's that part on the apparatus, and the upstream and downstream head is linked to those two tubes over there. Then we have the experimental procedure, how the data is captured. And then finally results. There's an explanation of what graph needs to be plotted, head loss versus velocity head, and also saying that all the raw data will be provided for this online lab. Then on the last page, there is a table of what the data is going to look like. There we have float height, upstream head, downstream head, and flow rate. These will all be provided to the student, but the rest, the velocity upstream, the velocity downstream, velocity head difference, and the pressure difference, and the head loss, all needs to be calculated by the student. In the paragraph down below, it also explains to you what will be provided to you in raw data and what the student needs to calculate and able to complete this lab. You will also need to do a questionnaire on Blackboard, which the lecturer will provide the link for you. Next video we'll go through the equipment we're going to use and how we capture the data. We're going to make use of the hydraulic bench again, fitted with a rotometer in the middle so we can control the flow through the system. But now the outlet of the pump, this big pipe, is connected to the K-factor apparatus. And on this apparatus we can measure K-factor for elbows and valves and all things, but we are only interested in the sudden contraction in a pipeline. So that's the big pipe going to a smaller pipe, so the contraction is sitting there, and then this is the upstream head, and that's the downstream head, measured with a inverted manometer. And if you follow the tubes, the H1 is the upstream one, and this is the downstream one, and we measure the head in millimeters. The data required for this lab will be done incrementally. We'll start with our rotometer again on 0, and remember that we take the reading on the float from the bottom edge. Then we're going to record the upstream head and the downstream head, and we're also going to measure the flow. Remember, we close the basin, the small basin that's inside here, and we measure how long it takes to fill 5 liters of water from one line to the next. You can also refer back to your rotometer lab how we measure the flow for each rotometer setting. Once we capture the data, we'll go to the next step. We'll jump 20 millimeters on the float on the rotometer. There we are on 20, and again we will record the upstream head and the downstream head And we'll measure the flow again by closing the basin again and measuring how long it takes to fill 5 liters of water. Raw data for your K-factor lab for a sudden contraction of pipeline will consist of the upstream head, downstream head, and the flow measurement per rotometer increment setting. Links to the raw data will be provided by a lecturer, and it will be up to the student to do all the calculations necessary to complete this lab successfully.